Hello, Math 30-2, and welcome to Lesson 1. So what we're going to be doing first is something called set notation and just types of sets in general. So it's going to be a little bit different than any kind of math that you've seen before. It's going to be probably kind of strange. It's not that hard, but it's just different, I'd say. So this is pretty much following along with your textbook. So your textbook's going to be a good guide for this. If we look at this first example, this one's in your textbook as well. It says, if you look at the provinces of Canada here, A says, using the two-letter abbreviation, so just like, A, B for Alberta, of Canadian provinces, list the elements of the universal set of Canadian provinces and territories. Use proper set notation. Okay, so this right here is what I mean by set notation. So what we're going to do is create our universal set, and in this case, we're going to call that C. So the way you'd write this is C is equal to, and then we use our funny brackets, and then you just start listing them off because the universal set includes all of the different provinces. So, okay, so I just paused it and wrote them all down because I didn't want the video to last forever. So if you need to pause it to catch up to what I've done here. So this is what we mean by a universal set. And I know that probably doesn't make much sense yet because you're like, yeah, well, of course. It's just saying everything you have there. But what we're going to start doing is making different sets, and then this will become a bit more apparent why we're doing it. Maybe. Okay, so it says one subset. So in your textbook there, too, I want you guys to be writing down what these definitions are on your sheet that I gave you. I gave you a sheet of all the different definitions. So subset was one of those definitions. A subset is an element that belongs to another set. So it's a subset. It's part of a set. So it says one of those is, or of C, is W, the set of Western provinces and territories. So it says write W in set notation. So we're going to call Western provinces are going to be from Manitoba over. So now you just write it the same way. W is going to just be, I can do better than that. All of our Western provinces and territories. Okay, so that's it. So that's our set of Western territories. So not too bad so far, right? We're just kind of making groups of things is all we've really done so far. Part C here says the Venn diagram represents the universal set C, and we're going to start drawing it like this. If you've ever seen Venn diagrams, I have an example on my website there at the top. A Venn diagram was just like this, right? And you've probably seen these, I don't know, in different, I don't know. I'm sure you've done this in elementary school where certain ideas overlap. So you've got a certain amount of something in this circle and then this circle, and they have an overlapping area. That's kind of what we're going to be getting into. The way we're going to draw this is a specific way where we're going to draw a square, and then our Venn diagrams are going to kind of go in the center. We've only got one circle for now, but that's kind of where we're going. We're going to label our universal set as C. That's going to you're just going to put a little C up in the corner there, and then a little W by everything that's in this circle here. And don't worry about like the shapes. Like I know this one's a square and that one's a circle. It doesn't really matter. We're just saying that the big thing here is that this circle is inside of this square. That's kind of the main idea. So now it says write the elements of W in the circle representing W. So we're going to do the same thing, but instead of writing it like this in set notation, we're going to write it as a Venn diagram. So inside W here, we're going to write down these things. Okay, so that's it. We're just saying all of those things are inside W in our Western provinces in that set. Okay, the second part here says the complement. Now, complement's another keyword that we need to know. So the complement are all the elements of a universal set that do not belong to a subset of it. So what we mean by that is everything that's not W. So it says the complement of W is W prime, that little symbol, we call that prime in math and physics a lot. So W prime, we're just saying that's the complement of W. And all that means is that's everything that W is not. So W prime, or the complement of W, contains everything that's not W, everything else that's in that universal set that's not our Western territories. So that's going to be really everything else. So in this case, that's going to be everything this way over, everything that's not W. So we'd write every province, not W. Okay, now write W prime or the complement of W in set notation. Well, that would just be W prime is equal to. Okay, so that's it. Now it says draw a circle representing W prime in the diagram. Does it intersect with W? So like I was saying before, usually when we have Venn diagrams, we were talking about circles that overlapped. But is there any overlap here? No, there's no overlap here. Our circle for... No, draw a better circle than I did. Our circle for W prime is not going to include those ones. It's going to include everything else, everything that we just put here. So our Venn diagrams here have no overlap. So then it says write the elements of W prime in W prime. So the elements here were just the provinces, right? So we wrote those in that circle. So now D says write the set of eastern provinces. How is E related to W prime? Well, I'm not going to write that out. You can if you want. But E is W prime. So you can say E here is going to be equal to W prime. They're the same thing, right? The provinces that weren't Western provinces, the complement of the Western provinces, those were the Eastern provinces. Okay, so part E says the territories of Canada. We're going to call that set T. So now just list the territories of Canada. So T is equal to, funny bracket, so that's it. So now it says the territories are a subset. So remember, a set of the Western provinces. Show this fact in set notation. So here's going to be the new thing. The way we write that is that you would say T, so the set T, and then subset, that's going to be a symbol that we're going to draw like this, like a sideways U. So subset of W. And it just means everything that's in this set, in set T, so their territories, is also in set W, right? Because if you look at your picture again, our set of Western provinces and territories was all of that, right? We're saying that our set of just territories is inside of that. So it's a subset of that bigger Western set. Hopefully that made sense. Okay, so that's kind of our notation that we're going to be using for that, like the sideways T. Sideways U, I mean, sorry, I was looking at the T. So now we can also say the territories are a subset of Canada, of the universal set we said. We called that C. Show this in set notation. Well, that would just be T is a subset of C. It's kind of confusing because my subset symbol looks like a C, but it would be, something like that, right? Subset of C. All right, so now it says, show in set notation that the territories are a subset of Western provinces and a subset of Canada. So just what we've done here, just got to put them in order now. So you'd say T is a subset of W, and which is a subset of C, right? One's just a subset of the other. Now the last part here says, show and label the subset of territories on the Venn diagram on the other side. Okay, so that's looking back at this Venn diagram that we made, right? One thing I'm going to do, though, I am going to just write Yukon down here. And then this is just going to look like a circle inside of this circle. So that should be a better circle, but that would be it, right? It's a subset. It's a set that's inside of that bigger set. So that's what it would be. This is entirely inside that one. Okay, so for F, it says write the set of all Canadian provinces south of Mexico in set notation. So are there any provinces south of Mexico? There's not, right? So this is what we're going to call an empty set. And like you've written down on your definition sheet, hopefully, and if you haven't, then go ahead and look in your textbook, gives it, like on page 7, gives the definition of this. And the symbol, but you would just write that like this. So we'd say M, so we called it M here, would be equal to, and we'd have our bracket, and there's a few ways to do this. One is just to leave it empty. So it's an empty set, leave it empty. There's just nothing in it. So that's one way of showing it. The other way would be to say m is equal to, and then we just write like a 0 with a cross through it. And that's another way of saying it's an empty set. So now another definition here, disjoint. So that's on your sheet. Make sure that you write down the definition of this one. Disjoint sets are just sets that never come in contact, so ones that don't overlap. So in that case, you can look back at this Venn diagram and see pretty easy that, remember our W prime here, which was the complement of W. That was also our eastern provinces too, right? That we could also just have like an E there. They were the exact same thing. So we can say that E and W, they're disjoint. They're not joined. That's what disjoint means. They're not joined together, right? They're not ever overlapping. Whoop. So we can say that those are disjoint sets. So E and W are disjoint sets. So E and W. But you could also say E and T, right? The Eastern Provinces and Territories, they never overlap. You could say, yeah, that's pretty much it. I think that's pretty much it. Okay. Okay, so I'm going to let you guys go ahead and do this one on your own. So it says create a new set, N, which will contain all provinces or all province abbreviations that start with the letter N. So only provinces that start with the letter N. So what do we mean by that? Would be like that one, and that one, and that one. So that's our new set, right? Only those ones. So now we're going to see we will have some subsets here, right? Ones that are going to be overlapping with other ones. How is that going to look? So what I would do is write down what these sets look like in set notation here, then draw your Venn diagram. So we're going to have probably 3 circles. Some of them might overlap, some of them might not. So that's kind of how that works. So give that a try and then show your teacher when you are done. Okay, so for this next one, it says write down all multiples of 4 from 1 to 240. If you write this neatly, I'll just kind of show you a way how to do this. It won't be too bad. The sample space will go pretty quick. So and the other thing I guess I should have mentioned, that what I mean by sample space, what we're going to be talking about when we say sample space, is just like writing down all of the numbers instead of writing it out in like our set notation. The sample space would just be like writing them all out by hand, usually like taking like a lot of time to do it. Okay, so what I would do is just start counting up by 4. So I go 4, 8, 12, 16, and then 20. And then if you start down in the next one, you can see there's going to start to be a pattern here. 24, 28, oh, not 88, 28, 32, 36, 40. So you can see this is probably going to be the easiest way to do it. So if you go through this, you can write down all of your numbers that way. That's going to be our universal set when we get all these numbers done. Okay, in the above sample space, circle the numbers that are multiples of 12. So then go through and figure out, okay, which of these numbers are multiples of 12. I'll let you guys do that. Answer each of the following questions in set notation only. Follow the left side of page 8 as a guide. Okay, so I'm going to help you with a few of these. It says use S to show all the numbers between 1 and 240. Show this in 2 different ways. So all the numbers, not the list that you made up here that were just multiples of 4. We're going to put all the numbers. So one way to do that would be to say S is equal to, and then write all the numbers. It would be 1, 2, 3. But since I don't want to do that, you could also go comma and then dot, and then pick up from there just with like 3 numbers closer to the end. So that would be 237, 238, 230. 239, 240. Probably didn't need 4 numbers there, but there you go. Okay, so you could write it like that. And then the other way of writing it would be to say S is equal to. And then what I would do now is I'd say, okay, such that, or I'd say X. So what I mean by X so far is it could be any number. So it could be X, but now I'm going to put restrictions on that X. So I'm going to say X, and then this line straight down, and you'll see this on page 8 of the textbook too. This reads x such that, and now you'd say, what are the restrictions that we're going to say? We're going to say such that x is greater than or equal to 1 and less than or equal to our biggest number, 240. And then you also need to say, because we're not talking about decimal numbers, we're talking about natural numbers. So natural numbers, remember, are numbers like 1, 2, 3, 4, like numbers that you can count, like countable numbers. So we're going to say where. So when we write this out, the comma means where, the way you would say it. So where x is any real natural number, or any, sorry, not just any natural number. And then close the bracket. So I know that part kind of confuses people, but we'll work on it to kind of get used to that idea. Okay, so now B says use F to show all the multiples of 4 between 1 and 240. So for that, we can say F, and then like just show like the first few here. So we could say 4, 8, 12, ... and then kind of pick up close to the end here. So 232, 236, 240. Okay, so that's kind of what we got going on there. The other way of writing this now would be, now here's the part that I found students kind of forget or kind of get a little bit confused on. You'd write lowercase f, so I'm going to say f such that f, that lowercase f, is going to be equal to 4x. And then you'd say where, now what are the restrictions on x going to be? So you'd say x is greater than or equal to, well, 1. And then the other side of this though, would it be 240? Well, no, it's only going to be 60, right? There was only 60 elements in this list. When you guys made your list, there would have been 60 different elements there. And then you just add the restriction where x is any natural number. Okay, so let's try to figure out what that all meant though. Let's kind of go back here for a minute. So we're saying that f, so what's in that set? It's going to be, we're saying this really just a number. So we're saying there's this letter f where x, or where that is going to be equal to 4 times whatever or however many numbers there are. So if you look back to your set here, you'd say in this first one, that's where x is going to be equal to 1. So 1 times 4, that would be 4. This next part here, that would be where x is equal to 2. So looking at this thing, that would be a 2 in there. 2 times 4, that's 8. The next one, where x is 3, that'd be 3 times 4, that would be 12. So this is kind of a map, it's kind of a road map of how to get these numbers in that set notation. So that's kind of what that means. So hopefully just kind of look over that, figure out like why there's that 4x there, figure out why there's only 60, why it's less than 60. Well, I can show you now, is because, you know, this would be x equal to 1, 2, this would be 3, 4. There's only going to be 60 of these things, right? So that's kind of where that comes from. So I'm going to let you guys go ahead and do C on your own though. So that's where there was multiples of 12. So what I would do first, make sure that you circle or put maybe like a different color or put a box around all of your multiples of 12 all the way through. And then it's going to be the same thing as the 4, but you're just going to have less. So it's going to be really the exact same thing as this, but I would imagine this would be a 12, and I would imagine that this number would be different. So I'm going to let you guys go ahead and do D as well. So in the sentence, explain what f prime or the complement of f might mean. What type of sets are f and f prime? Just looking at your definitions that you guys have on that sheet. So what kind of sets would those be? I mean, like, how are they related to each other, I guess might be another way of saying it. Okay, and I'll let you guys do E as well, and that's just saying, so give 3 subset relationships. So remember subsets, that's at like sideways U. So is S a subset of F? Is F a subset of S? You know, like that type of thing. So don't go by what I've written here. I'm just saying, like, oh, that's what it would kind of look like if they were. But you're going to you're going to write down the relationships that actually are subsets of each other. Okay, so I think I've given you guys enough to kind of work on here now. I want you to go ahead and do the rest too. So this is just a Venn diagram of the one you did above. And you're going to do this one as well. So that's it for the video. And then make sure you guys go ahead and do the assignment questions as well, please.